In our next example, we're given a rational function. We'll first find the domain of the rational function, and then we'll use several parts to graph the rational function. So we have f of x is equal to x plus 1 over x squared plus 2x minus 3. So first, let's talk about the domain. In order to find the domain, we need to let x equal any real number except values that make the denominator 0. So let's set the denominator equal to 0 and solve. And we can factor this. X plus 3 times x minus 1 equals 0. If we set each of these linear factors equal to 0, if we set x plus 3 equal to 0, we get x equals negative 3. And if we set x minus 1 equal to 0, we get x equals 1. So therefore, we can say that we can let the domain be the set of all x such that x cannot equal negative 3 or positive 1. Any other real number is okay. Let's move on to step 1 to help us graph this rational function. I'm going to rewrite f of x in its factored form as x plus 1 over x plus 3 times x minus 1. Now in step 1, we want to see whether we have any symmetry. Well, in order to check for symmetry, we're really looking for f of negative x. Let's go back to the original function for a moment. I'll substitute negative x everywhere I see an x. In the numerator, I have negative x plus 1. In the denominator, when I take negative x and square it, it's still x squared. Plus 2 times negative x gives me minus 2x, and then I have minus 3. This is definitely not the same thing as my original function. It would be the opposite if each and every term were the opposite, and I don't have that case either. So we can say that there's no symmetry here. Let's move on to step 2 and see if we have a y-intercept. We can always find a y-intercept by letting x equal 0, or in other words, finding f of 0. We'll get 0 plus 1 over 0 squared plus 2 times 0 minus 3. That simplifies to 1 over negative 3, or negative 1/3. Now let's see if we have any x-intercepts in step 3. We can always find any x-intercepts just by setting our numerator here equal to 0. So we'll have 0 equals x plus 1. This has a solution that x equals negative 1. So we have one x-intercept. Now let's move on to step 4. In step 4, we want to see if we have any vertical asymptotes. We do that by setting the denominator equal to 0. We already did that when we were looking for our domain, and we can see we had two solutions, x equals negative 3 and also x equals 1. So those are our two vertical asymptotes. Now in step 5, we check to see if we have a horizontal asymptote. We can do that by comparing the degree of the numerator, in this case it's 1, to the degree of the denominator, 2. Since the degree of the numerator is less than the degree of the denominator, we automatically have the line y equals 0 as our horizontal asymptote. Now, before I move on to step 6 and plot a few points, I'm going to put some of the pertinent information on the graph. We know there's no symmetry, but we do have a y-intercept at negative 1/3, so let's plot that. We have an x-intercept at negative 1, and we also have two vertical asymptotes. X equals negative 3 is our first one, and x equals positive 1 is our second one. And then finally, we have a horizontal asymptote, y equals 0. That's simply the x-axis, so I'll extend that with dotted lines. Now we're ready to choose some points. We want to choose points in between or to the left or right of our vertical asymptotes and our x-intercepts. So let's choose a value to the left of x equals negative 3. Let's say we'll let x equal negative 4. If we let x equal negative 4, and we can substitute that either into our original equation. Sometimes it's easier to substitute it in here into the factored form. I did substitute negative 4 in for x into the factored form, and I got the f of x value at negative 3/5. So negative 4, comma, negative 3/5 is on my graph, right about here. We already have the two vertical asymptotes, so let's choose a value in between x equal negative 3 and x equal negative 1. Let's say x equal negative 2. Again, I substituted into my factored form of my function, and I got the value positive 1/3. So we can say negative 2, comma 1/3 is a point on our graph. And then we can also pick a value here in between, say, negative 1 and positive 1 for x. I chose to choose positive 1/2. When I chose 1/2 for x, I substituted it in, and I got negative 6/7 for my y value. So at 1/2, I was down about negative 6/7. And then we can choose one more value to the right of this vertical asymptote. I let x equal 2. When I substituted 2 into my function, I got the value of positive 3/5. So let's plot that. 2, 3/5. Now we're ready to draw our sketch. We know that the graph will tend toward the asymptotes, so I can sketch it in here. And then in between the two vertical asymptotes, I can make a sketch. And then finally, to the right of my last asymptote. And here's a sketch of the function.